Welcome to this explainer. Today, we are absolutely unpacking the fascinating biological and psychological mechanics behind why we feel what we feel and what exactly drives our daily actions. We often think of our emotions and our logic as entirely separate things, right? Like oil and water. But today, we're going to dive into the hard science of affect. We'll uncover the hidden systems in your brain that dictate literally everything, from a sudden burst of fear to your deepest long-term goals. Let's kick things off with a pretty provocative quote from the pioneering psychologist William James. This is going to challenge our everyday common sense. He wrote, "We feel sorry because we cry, angry because we strike, afraid because we tremble." Think about that for a second. Do we run away from a bear because we're experiencing the emotion of fear, or do we consciously feel afraid because our brain notices our body is already running? It's a mind-bending question for sure, and it sits at the absolute center of understanding human emotion. So here is our roadmap for today. We'll cover 1. The basics of affect, 2. Inside the emotional brain, 3. Three theories of emotion, 4. Communicating without words, 5. The impact of stress, and 6. Drives, goals, and motivation. Okay, let's jump right into section 1, the basics of affect. So the absolutely crucial point here is that affect is basically an umbrella term that covers both our emotions and our motivations. And what's really cool is that both of these words share the exact same Latin root, which means to move. Unlike our calm, rational, cognitive processes, emotions and motivations are hot states. They inherently involve physiological arousal. We're talking about your sympathetic nervous system kicking into gear, releasing hormones like epinephrine, making your heart pump faster and your breathing increase. Affect literally gives our bodies the biological energy to move and respond to our environment. At the foundation of this whole system, we have the 6 basic emotions: anger, disgust, fear, happiness, sadness, and surprise. These are driven by the oldest parts of our brain. Because they're so deeply rooted in our evolutionary history, they're universally shared. Honestly, no matter what culture you're from, human beings experience and display these 6 emotions in incredibly similar ways. They exist for one main reason: to help us make rapid, split-second survival judgments. Now, to understand more complex secondary emotions, psychologists use something called the circumplex model. Unlike those basic survival emotions, secondary emotions require cognitive appraisal. That means your brain has to actually think about and interpret the situation. This model is like a giant map plotting these complex emotions on 2 axes. The vertical axis is your level of arousal, ranging from mild all the way up to intense. The horizontal axis is valence, which is just a fancy way of saying whether the feeling is pleasant or unpleasant. So feeling alarmed is intense and unpleasant, while feeling serene is mild and pleasant. Your brain basically takes your physical arousal and your cognitive thoughts, plots them on this map, and bam, creates your exact emotional state. Moving right along to section 2, inside the emotional brain. Let's look at the actual biological hardware. Deep within your brain sits the limbic system, which is your core emotional center. There's this small almond-shaped structure called the amygdala. It's primarily responsible for regulating our perceptions of and reactions to aggression and fear. Right nearby is the hypothalamus. Now, this is a tiny but mighty structure that links your nervous system to your endocrine or hormone system. It helps regulate body temperature, hunger, thirst, and sex drives. It essentially translates your emotional brain's commands into chemical signals, kickstarting pathways to flood your body with hormones. So how exactly does information flow through this hardware? Well, the thalamus acts as a sort of master gatekeeper, routing information along 2 distinct paths. Imagine a car suddenly pulls out in front of you on the highway. The thalamus sends that visual data down a fast pathway, straight to the amygdala. Boom, you slam on the brakes before you even consciously realize why. That is a pure survival reflex. But at the same time, the thalamus sends that exact same data down a slow pathway through your frontal cortex for complex cognitive analysis. This is exactly why you feel the immediate, paralyzing terror first. And then, a second or 2 later, you feel complex anger or relief once your cortex actually analyzes what just happened. That brings us perfectly to section 3, 3 theories of emotion. Time to decode the software running on that hardware. We're going to compare 2 historically opposing ideas here. On one side, we have the Cannon-Bard theory. This states that physical arousal and the subjective emotional experience happen at the exact same time. You see a threat, and your heart pounds literally while you feel fear. But on the other side, we have the totally counterintuitive James Lange theory, going right back to that William James quote from the start of our explainer. This theory argues that our physical arousal actually causes the emotional feeling. Your heart pounds first, your brain notices the pounding, and therefore you feel fear. Building on this, the modern consensus is the Schachter-Singer two-factor theory. It basically says that identical physiological arousal requires a specific cognitive label to create our final emotional experience. The formula is literally emotion equals arousal plus cognition. If your heart is pounding, that's the arousal factor. But you need the cognitive factor, your brain looking at your surroundings and saying, hey, I'm looking at a dangerous car, so this pounding heart must be fear. If you were looking at an attractive person, your brain might label that exact same pounding heart as excitement or lust. The physical feeling is exactly the same. It's the cognitive label that dictates the emotion. Okay, section 4, communicating without words. Let's look at everyday behavior. We broadcast an immense amount of emotional data non-verbally. This happens through our posture, our use of personal space, which is known as proxemics, and massively through our face. Get this, the human face contains 43 distinct muscles that can be arranged into over 10,000 unique configurations. Without saying a single word, we can instantly communicate everything from subtle amusement to profound distress. It's a highly adaptive evolutionary trait that lets us understand the intentions and feelings of others in a split second. Actually, scratch that. It's not just a one-way street from your brain to your face. Even more fascinating is the facial feedback hypothesis. This proves that the physical act of moving your facial muscles can actually trigger the corresponding emotions in your brain. There are famous studies where researchers had people hold a pen in their teeth, which physically forces the face into a smile, and those participants actually rated cartoons as funnier than people who held the pen in their lips, which mimics a frown. You don't just smile because you're happy. You can actually become happier simply by forcing a smile. Your brain reads your facial muscles to help determine how it should feel. Crazy, right? Next up, section 5, the impact of stress on our bodies. Biologically speaking, stress is way more than a passing mental state. It is a profound physical arousal that floods the body when we face a threat we feel we just cannot adequately handle. It triggers extreme negative emotions and totally hijacks our autonomic nervous system. It prepares the body for a massive fight or flight response that, let's be real, in our modern world, we rarely actually execute. When stress doesn't go away, our bodies undergo what researcher Hans Selye formulated as the general adaptation syndrome. First, there's the alarm phase. Your body releases stress hormones like cortisol and adrenaline. If the threat remains, you enter the resistance phase. Your body tries to adapt to the ongoing stress, basically running at an unsustainably high level of physiological arousal. Finally, if the stress continues long-term, you crash into exhaustion. Your body's reserves are totally depleted, leading to severe illness, weakened immunity, and physiological breakdown. It shows exactly why chronic stress is so incredibly damaging to our health, and why deliberately cultivating positive emotions is absolutely crucial to buffer against these effects. Finally, section 6, drives, goals, and motivation. How we seek balance. To really understand motivation, you have to understand homeostasis. Think of homeostasis like an internal biological thermostat. Your body always wants to remain perfectly balanced. When your physiological balance is off, say your blood sugar drops because you're hungry, that thermostat clicks on. This creates a psychological drive that motivates you to seek a goal, in this case, eating, to restore that balance. And once the balance is restored, the drive turns off. Simple as that. This thermostat mechanism is what drives our most fundamental biological actions. Eating, for example, is driven by physical hunger hormones, sure, but it's also heavily motivated by social and cultural cues. Mating and sex are fundamental evolutionary drives regulated by our brain chemistry. But human motivation goes far beyond mere survival. The exact same mechanisms that drive us to find food also govern our profound psychological need for social approval, acceptance, and achievement. We are driven to restore balance in our social lives and self-esteem just as intensely as we are driven to find a glass of water when we're thirsty. As we wrap up this explainer, I want to leave you with one final powerful thought. We've seen today that your emotional reality is basically just physiological arousal combined with a cognitive label. So if your feelings of anxiety, stress, or even a lack of motivation are simply physical arousal waiting for a cognitive label, how much power do you truly have to rewrite that label? The next time your heart starts racing, will you label it as paralyzing stress, or will you appraise it as the energizing excitement you need to tackle your goals? The choice, it turns out, might literally be entirely in your mind.